మర్చిపోయినది అన్నది ఇదే. Hello, good noon students, how are you all? So welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. In the NEET one shot session series, we are going to discuss about hydrocarbons in one shot in the part 1. It is going to be our part 1. So in this part 1 we are going to discuss about alkanes and alkenes. Okay, in the part 2 we will be discussing about alkynes and arenes. And in the part 1, in the hydrocarbons, we are going to see the preparation and properties and conformational isomerism in the alkanes. And in the alkene preparation and properties, we are going to discuss all these things, all electrophilic addition, reaction, Markovnikov, anti-Markovnikov things and all. Okay, get ready. One thumbs up and fire emoji, everybody. Yeah, please confirm. Yeah, please confirm you are all able to see me, can hear me in the chat box quickly. Well, so before going for the series start, we already connected with this one shot series where we completed the other topics like general organic chemistry and all. There we had a quick revision about all the topics. Hi Tribeni Roy, how are you? ये महीने में सारे के सारे टॉपिक्स ख़त्म कर लेंगे, ठीक है? एवरी alternate days 12 o'clock, stay tuned, right? And in this I want to say we had completed NEET NCERT series and the NEET most expected questions 1000 question series. Again we are come up with one shot series. Yes, now before we start with this oath of the day, it is going to be crack your NEET. For that we have every day take a oath. What we are doing for what? It is nothing but for preparation for the NEET examination, cracking the NEET examination. For this every day please attend the sessions without any failure, and if you fail to attend the session on live, please watch the recording. Please like the session, share with your friends and subscribe to Infinity Lane NEET YouTube channel. And this series is new, and this series gives a lot of boost and support for the students preparing for NEET examination. And Chandan, very good. And let's see. And in the NEET, you can see in the Google Play Store, you are having a Infinity Learn app where you can access live classes, mock test, and create your own test and 24/7 doubt resolution sessions. So let me give you one more promotional slide, then directly we will go into the concept, right? Get ready. Hi, Anushka Rai, it is series for new. Well, now whenever you are preparing for some examination, it is required to understand where exactly you stand and how you are preparing, what is your improvement areas and all. For that you need to have a proper assessment platform. Infinity Learn designed, scientifically designed the assessment platform and introduces All India Test Series NEET 2025. And for that benchmark yourself against India's best assessment platform, and you are going to have 34 full syllabus tests and 14 grand tests, 20 mock tests, and also detailed video solutions for each and every question for every solution. So dear students, the cost, it was 80% flat discount is given for any student. For it was 5,999, round it up to 6,000. Okay, जल्दी start कर लेता हूँ, ये आखिरी slide का है, and it is coming to be 1199. And when you apply YT80, the coupon code YT80 coupon code enter करना है, so you are going to see YT80. Okay, then you are going to see this 80% discount. Definitely you can see. Okay, anyways, Digvijay. Well, so let's start the session without any delay, right? So in this hydrocarbon, the topics that we are going to see, it's pretty simple. Hi, it is about alkanes and alkenes and alkynes and arenes. This is the major course for the entire hydrocarbons. So I want to say, total NEET examination, it is about organic chemistry is about 33 to 35% कम से कम आने वाला है. So among the entire organic chemistry, the base grip is given by GOC and hydrocarbon. Once you are very good at alkanes and you can handle alcohols, you can handle alkyl halides, है ना? And organic chemistry is something like integrated topics. So alkene is connected to alkyl halides, alkyl halide is connected to alcohols, alcohol is connected to carbonyl compounds, and alcohol is connected to amines. है ना? That's true. So a peace of mind, and everybody take a pen and paper and be lot of patience, and each and every point I just want to discuss about each and every reaction, stay with us. Okay, so let us talk about the alkanes. Alkanes, it is saturated hydrocarbons, and it is a homologous series, everything methane, ethane, propane. So it is not a grade 11 class, it is a NEET examination. एक महीने में maximum you have a month and 45 days time. We are in the last round of preparation. This NEET series is launched in the month of May, and in the 2024 we have been covering each and every topic from the NCERT. One round is completed, then we have gone with one short series, and we have gone with MCQ series and 1000 most important question series, and final round of revision series is going on. Chandan, yes, so lot of patience. The content is going to be delivered right now. It is going to be preparation of alkanes. You can prepare alkanes from unsaturated hydrocarbons ताकि आपको R CH2 double bond CH2 and R, if it is added with hydrogen by using a catalyst, okay, so you are going to get hydrogen being added, you are going to see R CH and CH2 and R. So alkane is formed. Alkene can give alkane, and this reaction is said to be Sabatier and Sanderson reaction, or Sabatier-Sanderson reaction. अलग-अलग book में अलग-अलग तरीके दिया. Okay, so if it is an alkyne also, you are going to get like this, H2 in the catalyst. Now I want to say what kind of catalyst आप इस्तेमाल कर सकते हैं उसमें. So many things I want to say here. Let's say the catalyst that can be used for this process. You can use nickel as a catalyst, even platinum as a catalyst, palladium as a catalyst, rhodium as a catalyst, sometimes iron as a catalyst when you heat it. Okay, so I just want to say here various good things. Anushka Roy, yes. PF, PT na? PT, it is PT. Okay, you can use Rane nickel, very famous one, Rane nickel. Adsorbed, hydrogen gas is adsorbed on the nickel powder. It is called as Rane nickel. Alnico is an alloy, it is soaked in the sodium hydroxide so that aluminum is going to be formed, and sodium metaluminate is formed so that a nickel granular form is formed along with that hydrogen gas is going to be adsorbed, and it is stored in ethanol, and it is called as a Rane nickel, and it is widely used. High surface area के बारे में maximum high amount of active hydrogen can be stored by using Rane nickel. So that is the importance of this Rane nickel. It is connected to surface chemistry. Of course, it is out of syllabus. Talking about here, it is a syn addition. It is a surface catalyzed reaction. It is a syn addition. I just want to say here, if you take a cyclohexene, when you add D2 and with the presence of a platinum or a palladium or a nickel as a catalyst, you are going to get a syn addition product. Okay, so that is going to be like this. Okay, D and D. So it is not a trans addition. Syn addition means addition to one side of the double bond is called as a syn addition. So it is a stereospecific reaction. I am going to tell you the importance of the stereospecific reaction when you go for this alkene reactions as well. Okay, you can't stop this reaction. This reaction is given by Sabatier and Sanderson, they got a Nobel Prize to explain this reaction, and this is very, very important reaction. And let us go ahead with some other kind of reaction for the preparation of an alkane. Each and every reaction is being explained in this. So if you want to study this reaction, open a book and you can refer it. And in the revision classes, when the teacher is explained in each and every point with its corner, so इसमें कौन सा क्वेश्चन आने का भी संभावना है, so questions also being discussed in such type of classes, so that it is going to be super important session. Stay tuned. Okay, so YouTube में क्या चलता है ना, students will come and visit and stay for 10 minutes and then leave. This is not actually a good practice. I strongly recommend you guys take a pen and paper and feel like it's a live interactive session, and you please write it, and you can discuss anything by using a chart box. So I am continuously tracking this chart box, and I am reciprocating the chart box by everybody's name here. Anushka Roy is there, Digvijay is there, Chandan, and we have Tribeni is there. So these are the students. I can say Tribeni is a regular student, Anushka is a regular student, okay, and many more students yet to come. I am waiting for them. Never leave the class. Come on, next one is decarboxylation. What is the meaning of a decarboxylation? What do you understand by deforestation? So cut the tree. So decarboxylation means cut the forest is called as a cut the carboxylic group is called decarboxylation. So here whenever you can see RCOOH, it is heated with, it's a carboxylic acid in the presence of calcium oxide and sodium hydroxide. So you are going to see calcium oxide and sodium hydroxide, that mixture is called as a decarboxylation mixture. This is called as a soda lime. You can say this is a soda lime. Okay, so I will tell you everything about this soda lime. So this soda lime is going to remove the carboxylic group here, and it is going to form RH is the alkane, and carbon dioxide is eliminated. Actually it is going to form as a sodium carbonate, okay, because sodium hydroxide is there now. And here मान लो इसमें n नंबर कार्बन एटम है जो अल्केन फॉर्म कर रहे हैं ना, इसमें n नंबर -1 कार्बन एटम रहना संभावना है. Why? Because it is decarboxylation. One of the carbon is removing it, so that this is the conversion where you are going to decrease one carbon in the product side. So students, any doubt? So let's see here. CH3, CH2, COOH. Okay, you can say it is a propanoic acid. When you heat along with the soda lime, calcium oxide plus sodium hydroxide, and you are going to get CH3 and CH3 and CO2 is formed. Okay, so in that, this is ethane. You just check the number of carbons. इसमें 3 कार्बन्स हैं, इसमें 2 कार्बन है क्योंकि उसमें कार्बन हटा दिया. So what is the role of Anushka? Yes, what is the role of calcium oxide? What is the role of calcium oxide? Calcium oxide acts as a dehydrating agent. That is very, very important. Now, during this decarboxylation process, you know, carbanion is going to be formed. Okay, so the NEET examination question. What is the probable chance of getting NEET examination questions? Okay, chance 1. A reactant will be given, you are asked to get a product, and a product will be given, you are asked to get a reactant. Okay, and so the reaction based question. And one more important thing, ease of decarboxylation. That is directly proportional to stability of carbanion. स्टेबिलिटी ऑफ कार्बोनियन, कार्बोनियन कौन सा कार्बन में फॉर्म होना है? So carbanion should be formed at this carbon once it is lost, mind it. So you have to check which carbanion is directly forming. That is going to be super awesome point. Okay, and very important trick, very important trick I just want to give you. That is about, Anushka Rai, beta keto acids. Beta keto carboxylic acids easily decomposes. Easily decomposes on heating. You need not have to add decarboxylation mixture, soda lime as well. You can see, my dear children, here this is a COOH, this is your alpha carbon, and this is your beta keto carbon. How do you say this is alpha and beta? Look at this. With respect to this is alpha, and with respect to this is going to be beta. Okay, this is called beta keto carboxylic acid. So when you heat it, what are you going to get it directly? You remove the carbon dioxide. You don't have to add, need not have to add this soda lime. Just heat it. And when you just heat it, simply this is eliminated, and the product that you are going to get is, don't disturb the keto group. Okay, and this is last now, and this is end, where you are going to see this. So of course alkane is not the product, rather you can say it's a carbonyl compound, and this kind of questions are very important in solving. Key point, descending conversion. Descending conversion. So number of carbons in the reactant side and the product side में एक number carbon कमी होना चाहिए. Anushka Rai, Tribeni Rai, come on. Any doubt? Chandan Mohan? Chandan? Expecting your response. My dear children, stay tuned. I am going to give the very valuable information. Just a minute. Right? That's good. Now आगे बढ़ते हैं, और एक चीज़ है, डिकार्बोक्सिलेशन का अलग अलग प्रोडक्ट देना चाहिए, and by reduction of alkyl halides. So when you go for the reduction of alkyl halides, you are going to get alkyl halide. When it is reduced, so the hydrogen is replaced with a halogen, so it is going to get an alkane, right? So in this, what is the reducing agent you can get it? So you are going to get zinc and acetic acid, or also you can expect zinc and HCl, zinc and sodium hydroxide, zinc copper couple, aluminum amalgam, and also you can have sodium in ethyl alcohol. Okay, you are going to have HI in red phosphorus. You know, HI in red phosphorus is going to be a super reducing agent in the organic chemistry, mind it. These are all the super organic reactions, reducing agents. But also you can use lithium aluminum hydride. You can use sodium borohydride. Okay, so these are all very good reducing agents. You can see they are going to provide the hydrogen, and this hydrogen is going to be a super reducing agent for this. Let us see a couple of reactions for this. Okay, now we can see alkyl iodides are produced by HI in red phosphorus under high temperatures. Okay, and you can have Wurtz reaction. It's a very famous reaction. What is the Wurtz reaction? What is the Wurtz reaction? Okay, going back to this, a quick thing I just want to give you. So it is a 2-chlorobutane. If you use lithium aluminum hydride, I would get butane. So if I want to say cyclohexyl chloride, if I use a zinc and HCl, it is going to get cyclohexane. If I want to see chlorobenzene, if I use zinc and HCl, इसका प्रोडक्ट क्या होगा? इसका प्रोडक्ट क्या होगा? अनुष्का राय एंड दिग्विजय सिंह चंदन, कमान त्रिवेणी, गिव द आंसर, जल्दी दे दो. बेंजीन देता है, रिएक्शन नहीं होगा. ये जो बॉन्ड है ना क्लोरीन बेंजीन का बीच में आता है, एनी बॉन्ड दैट इज डायरेक्टली अटैच्ड टू बेंजीन, it is difficult to operate by using normal methods. It is a fundamental rule you need to have in the chemistry. Fine. हाँ, क्योंकि इसका पार्शियल डबल बॉन्ड रेजोनेंस के वजह से निकलेगा. ओके, सो पार्शियल डबल बॉन्ड के करना बहुत मुश्किल है. फाइन, रिगेटिंग और नॉट. डेविड की क्या बात? यस ऑफ कोर्स. नाउ वुड्स रिएक्शन है. वुड्स रिएक्शन होता है क्या? ओके, सो वुड्स रिएक्शन, whenever alkyl halide is treated with sodium metal in dry ether, you are going to see the formation of an alkane. This is what is called as a Wurtz reaction. So, David, you said some P, I don't understand. So, I want to give you an example for this, a beautiful example, CH3Cl. When you use sodium in dry ether, DE stands for dry ether here, you are going to say CH3 and CH2 plus 2 NaCl. उसमें क्या चीज़ है? So I want to say here, dear children, very simple, reactivity of alkyl halide. Reactivity of alkyl halide. Okay, primary alkyl halide is more reactive than secondary alkyl halide is more reactive than tertiary alkyl halide. Okay, tertiary alkyl halide usually do not. That's very, very important. एंड गुड थिंग्स आई एम जस्ट गिविंग यू. ये जो ऑर्डर्स देते हैं ना हमारे क्लास में, ये ऑर्डर्स के हिसाब से आपका क्वेश्चंस आने के ज़्यादा संभावना होगी. ओके, नाउ अल्काइल आयोडाइड इज मोर रिएक्टिव देन अल्काइल ब्रोमाइड इज मोर रिएक्टिव देन अल्काइल क्लोराइड इज मोर रिएक्टिव देन अल्काइल फ्लोराइड. सो अल्काइल फ्लोराइड डू नॉट रिएक्ट इन द Wurtz reaction. Anushka, come on. Now, here I just want to say Wurtz reaction, Fittig reaction, Fittig reaction, Franklin reaction, many things are there. Okay, so what I want to say here, if it is written like this, okay, so if you use sodium metal and dry ether means I can use a tetrahydrofuran. What is this tetrahydrofuran? This is your ether, this is your tetrahydrofuran. It is a cyclic ether and extensively used as a solvent for so many organic reactions. Okay, tetrahydrofuran, you are going to get the compound like this, of course, right? Okay, very good. And if it is given like this, and now what I want to say here, one equivalent of sodium and dry ether is used. So when you use one equivalent of this, here the chlorine and the bromine, look at this, bromide is more reactive than chloride, है ना? ब्रोमाइड इज मोर रिएक्टिव देन क्लोराइड. इसके वजह से ब्रोमाइड रिएक्ट होता है क्लोरीन बिना छोड़ के. सो दैट व्हाट हैपन, you are going to get a bond between two cyclobutane rings where chlorine is attached at this third position. So this is one, a product can be seen, and this is the kind of questions that is previously explained. Okay, and this is about the Wurtz reaction, and what could be the alkane that can yield a product 2,3-dimethyl butane. So that kind of questions will be asked. You have to check it. This is a more prone reaction for NEET examination. So it should be with symmetrical. So when you talk about this product, split it actually, so that this is a part of alkyl halide, this is a part of alkyl halide. So आपका आंसर आ सकता है ऐसा, let it be chloride or let it be bromide or let it be iodide. So it is in the presence of sodium in dry ether. Of course it is sodium in dry ether. Whenever ether comes na, it is going to be THF, diethyl ether, and so many things can be seen in this way. Fine. Okay, 2-chloropropane. Anushka, that's good. David, and what are the limitations of Wurtz reaction? Limitations of Wurtz reaction. Which require a lot of maturity to do this. So methane cannot be prepared. Dear children, methane cannot be prepared. Wurtz reaction is a coupling kind of reaction. When it is a coupling kind of reaction, two atoms should come and attach. So two carbons should come and attach. So methane has only one carbon, so it cannot be prepared by using coupling reaction. Understand? Alkanes with odd number carbons are not preferred. Preferred, I said, I don't say it can't be prepared. So why it is not preferred? So it requires a lot of sensible thinking ability. Can you prepare propane? Yes, I can prepare by using a Wurtz reaction, but I can't use it. Why? Let me tell you. So here methyl chloride is reacted with ethyl chloride in the presence of sodium in the dry ether THF. Let us see here. Let us see what are the probable products that can be seen. The probable products that can be seen here. See the color I am using, you can understand the virtue of how the reaction is taking place. Methyl chloride can couple, so ethane can be formed. Ethyl chloride and ethyl chloride can couple, so that you are going to see CH3, CH2, CH2 and CH3 butane is prepared. So you got ethane, you got butane, and also you are going to get methyl chloride and ethyl chloride can couple. So you are going to get CH3 and you are going to see CH3. Yeah. Now let us say name it here. It is going to be ethane. It is going to be butane. It is going to be propane. I can make it. But the problem kya? So, one rule everybody mind it. NEET examination is not going to ask you how depth of the subject you know it. Rather, NEET examination paper is going to be prepared in such a way that your application ability, your understanding ability, okay, mind it. So, these alkanes do have the boiling point values so close. When the boiling point values are almost similar, okay, it is going to have minus 16.5, it is going to have minus 14.5, something like that. So such a close boiling points, you can't separate it due to, how do you separate the alkanes? By using a fractional distillation only. So by using fractional distillation, boiling point में फर्क होना चाहिए. So लेकिन इसका boiling point बहुत बहुत close values में रहते हैं. So that due to very close boiling point values, mixture of not separated, mixture is difficult to separate, I can say. That's the reason why propane is not preferred. Propane is not preferred. Mind it. So I just want to say here under assertion, and this is going to be a reason, and assertion is true, reason is true, and reason is the correct explanation of assertion. Mind it. Got it? Clear? That's good. Any doubt, my dear children? And this Wurtz reaction, you know, it prefers, you have ionic mechanism, you have free radical mechanism, but the free radical mechanism is preferred. Ether supposed to be dry. Ether supposed to be dry. You can say dry ether. Then only sodium is going to provide you the radicals. Then only radicals can be formed. Right, Paul? Array, I am from +1, +2, anybody want +2. And these are the important reactions. Those who are preparing for 12th standard also, this kind of reactions are pretty much important, right? Okay, let's see. Pahul, for you, you are in the 12th standard now, I'll give you Rex. When you use sodium in dry ether, DE stands for dry ether. You are going to get R and R. Okay, plus 2 NaX. If it is a benzene ring, whenever it is going to react with sodium and dry ether, okay, you're going to get diphenyl or biphenyl. You are going to get diphenyl or biphenyl. Fine, Anushka Roy. If it is alkyl halide and aryl halide, बीच में sodium in dry ether होना, तो you are going to get alkyl benzene. You are going to get alkyl benzene, right? ये reaction का नाम क्या है आपको पता ही होगा. This is going to be a Wurtz reaction. This is going to be a Wurtz reaction. Okay, Anushka, Pahal, you tell me the name of the reaction here. You tell me the name of the reaction. It is going to be a Fittig reaction. It is going to be a Fittig reaction. Dear children, focus on here. If this and this is combined now, it is going to be Wurtz-Fittig reaction. It is going to be Wurtz-Fittig reaction. Yes, of course. So everybody should have a total command on the reactions that you are going to study. Don't focus on by-hearting the things and all, right? Stay tuned. Any doubts? Paul? Pahul? Wonderful. Next. Okay, आगे बढ़ता. Pahul, come on. Anushka Roy and Tribeni. Next one is a Frank-Land reaction. What is this Frank-Land reaction? आपका जैसे RX है, when you use sodium in dry ether, you are going to get an alkane. This reaction, you all say it is a Wurtz reaction. So far we studied that only. When you talk about the same, when RX is treated in the presence of zinc and dry ether, so instead of sodium, we use zinc, you are going to get alkane again. That is going to be. So this is about the Frank-Land reaction, just like as it is in the Wurtz reaction. अगर कुछ doubt है ना तो पूछना. So learn chemistry in such a way that one is connected to another. So don't feel that chemistry is hundreds of chemical reactions that we are studying. So chemistry is so awesome if you connected, right? Now let's talk about reduction of alcohol. How do you reduce alcohol? Bapre. Yes, you can reduce alcohol. Yes. It is going to be alcohol. When alcohol is reduced by using red phosphorus in HI, it is going to be super reducing agent. HI in red phosphorus, you are going to get an alcohol. So reduction ऐसे भी हो सकता है. Now you can see the OH, HI in red phosphorus, you are going to get like this. Got it? And when you talk about you would be getting like this. Understand? Butane and cyclohexane. Cyclohexane. Fine? Now reduction of aldehydes and ketones. So we have two types of reactions. Okay, so what is that two types of reactions? It could be aldehydes and ketones. This is your aldehyde or a ketone. This is called carbonyl group. This is your carbonyl group. Let us go for its reduction. So it can be reduced by using, zinc amalgam and HCl, zinc amalgam and HCl, and you can also go for reduction by using NH2 and NH2 in the KOH. You are going to get the same product, CH2, and you are going to get CH2. Okay. So can you, Anushka, you tell me, can you say the name of the reaction here? Name of the reaction over here, it is going to be Clemmensen reduction. It is going to be Wolff-Grignard reduction. It is going to be Wolff-Grignard reaction. So आप ये भी इस्तेमाल कर सकते हैं, ये भी इस्तेमाल कर सकते दोनों. But here Clemmensen reduction is in the presence of an acid. So If any group that is acid sensitive, you cannot use a Clemmensen reduction, and this is a Wolff-Kishner reduction. This Wolff-Kishner is having a base. Any group that is present in the base sensitive group, you cannot use this. So that is very, very important. So if it is an acid or a base and further anything is there, we have to check with this sensitivity of the further groups. Okay. So let's talk about what could be the product over here. Let's talk about what could be the product over here. Still we are in preparation of alkanes. So in the entire preparation of alkane, we are discussing each and every reaction with a very good number of examples. So stay tuned. Anushka Rai, Pahul, David and Tribeni Rai. Wonderful, wonderful. So अगर आपको कुछ डाउट मिलेंगे तो आप पूछ सकते हैं, ठीक है. Now we can see here. So this is your like this. So when you treat with zinc amalgam and HCl, so double bond को कुछ नहीं होगा and it is going to be like this. Okay. So let it be double bond. मैं हटा देता हूँ. So confusion आ रहा है. Understand? Clear? Wonderful. Let's see further reactions. Further reactions. Kolbe's electrolysis. Kolbe's electrolysis. So electrolysis of sodium or potassium salt aqueous solutions, we are going to get respective hydrocarbons. This is called as Kolbe's electrolysis. So let's talk about the Kolbe's electrolysis here. CH3COOK, potassium acetate. This is your potassium acetate. इसमें ये electrolyze करेंगे तो क्या चीज़ मिलेगा? So let me write one more thing here. Yeah, similar to this CH3COOK. So what I mean to say, whatever you are learning, learn from the technique. Okay, yeah, I am going to give you a simple trick. Aqueous solution of this is electrolyzed. So aqueous solution means water is there na. If you permit me, I want to write water as HOH, H plus OH minus. Okay. So on electrolysis, what happened, you know? So there is going to formation of a KOH. इसका हिसाब से आपका प्रोडक्ट 2 KOH बनेगा ना? हाँ, yes. That is CH3COOK, Anushka Roy. Okay, now we are going to see. It is going to be H plus and H plus. आपका आता है H2 gas. It is going to be H2 gas. ठीक है? H2 gas. Now I just want to remove CO2 and CO2. So 2 CO2 मिलेगा. And you are going to see the formation of CH3 and CH3. And these are formed at anode and this is formed at cathode. है ना? And NEET examination में क्या क्या चीज़ आने वाला है बेटा? Okay, sodium acetate. This is sodium acetate. Or sodium ethanoate. You are going to get ethane as a product. And the products formed at anode में क्या होगा, cathode में क्या होगा? And of course, it is a decarboxylation reaction. Very good. Yes. Now you tell me. What if this is electrolyzed? In the aqueous medium. what you are going to get. Like these questions will be there in the NEET examination, mind it, what could be the product. So, this is the carboxylic group is exiting, this is the carboxylic group will exit, so that this is the point of contact for you. Okay. So, this point, okay, we have to write as it is. Got it? Digvijay. And we are going to take the same kind of point and rewrite. It's a coupling reaction, no? Right? Now, there is supposed to be a new bond that is established between these two. So, this is the one, this is the one. So, I want to say in R otherwise, 1, 2, 3, 4, 5, 6. So, it is 5 now, 2, 5 dimethyl hexane is the product. So, what could be the product for this? 1, 2, 3, 4, 3 methyl potassium salt of 3 methyl butanoate. Anushka Rai, got it? So, things are going to be so easy once you understand the thing. Otherwise, it is going to be very, very difficult. Okay? Understand? Clear? Okay. You want another one? Okay. Will do. From Grignard reagent is very important. What do you understand about a Grignard reagent? When alkyl halide is treated with magnesium in dry ether, you are going to get RMgX. This is called as a Grignard reagent. This is called as a Grignard reagent. So, what do you understand by the Grignard reagent? So, an example, CH3Cl, when you treat with magnesium in dry ether, you are going to get CH3MgCl. Whenever you talk about the Grignard reagent, you need to take 2 points into the action. Grignard reagents plus and minus. So, because of this, okay, it is an excellent base. It is an excellent base and a good nucleophile. Excellent base and a good nucleophile. Okay. So, base means, what do you understand by the base? So, learn chemistry like this. What do you understand by the base? It love to attack on H plus. It love to attack on H plus. So, it attack on H plus. Accept H plus. So, what I mean to say here, R minus and Mgx plus. So, R Mgx minus and plus. So, whenever it is reacted with H plus, whenever it is reacted with H plus, so what is going to happen? It is going to attack over here. Yes, base, it's a base, it love H plus. Hegina. So that you are going to see R and it is going to be H alkane. It is going to be alkane. Yes. Who is going to give the H plus? Any species which can donate H plus can give. I am going to give you the list of the species. Like you see, H2O can give you H plus and OH minus. He can use H plus. He can use H plus. Are you getting or not? You can use alcohols, can give you H plus or O minus. You have phenol, okay, can give H plus and phenoxide ion. Many things are there. Many things are there. A terminal alkynes can undergo or C triple bond or C triple bond CH can give you or C triple bond C minus and H plus alkynide ion. Terminal alkynes are acidic, I already mentioned, and we will be discussing these kind of things in this organic chemistry alkynes part. In the part 2 of hydrocarbons, you can have HCl can give rise H plus and Cl minus. You can have NH3 can react with H plus and NH2 minus, what not, many things. So that require a lot of commitment and involvement. In the primary amines can give rise are NH minus and H plus. Okay, like that, what not, CH3, COOH can give you CH3, COO minus and H plus. Okay, अनुराग सिंह आप भी देख सकते हैं, anybody, because organic chemistry, organic and inorganic chemistry same आता है ना, लेकिन ऑर्गेनिक जेईई में थोड़ा सा अलग तरीका क्वेश्चन आना वाला है, अंडरस्टैंड. Right. Any doubts? Now, I have a question. Anushka, this question is for you. Okay, we can do this. Complete the reaction. Digvijay, Anushka Tribeni, Anurag Singh, complete the reaction. Complete the reaction, I want to see. X is RMG. What is that? Okay. So it is going to be like this. Of course, I know it. Yes, congratulations. MgBr. And iska Y? RD. Very good, Digvijay Singh. It is going to be like this. Deuterium. You know, this is going to be optically active. This is going to be optically active. Fine? Super question. So, this is going to be optically active. It is going to have its enantiomeric pair. How many fractions you are going to get in the product? How many fractions you are going to get at the product? Only one, because enantiomeric pair is going to be one fraction, because enantiomers are going to be optically active compounds and they are non-superimposable mirror images, but they have the same physical and chemical properties, therefore they have the same boiling point, they comes under the same fraction. Digvijay, you understand? So when you keep on discussing these organic chemistry concepts in depth, it goes like this, but superficial level it should be. Okay, unnecessarily I just want to Simmons-Smith reaction in the middle of the organic chemistry and I want to say this is the depth of the subject, आपको कुछ फायदा नहीं होगा. Understand? Simmons-Smith reaction is not there in the NEET, NCERT में नहीं है. So जो भी NCERT में है इसका हिसाब से आपका अच्छा तरफ पढ़ाई करके आगे बढ़ना है. Understand? Clear? So next is going to be reaction by action of water on aluminum and beryllium carbide. So metal and non-metals. Here non-metal forms an oxygen compound, it is a non-metal oxide, it is supposed to be generally acidic. Metals are going to be forms a binary compounds with oxygen, it is supposed to be dissolved in the water to give rise either basic or amphoteric, mostly basic, okay, and a few are amphoteric. So metal oxide on hydrolysis gives a base, a few are amphoteric. Similarly, metal is going to form a binary compound with carbon, they are called as a metal carbides. So the metal carbides are going to give you the products called hydrocarbons. Enam? Pratyush, hello. So as I mentioned, this is a live interactive session. If anybody want to have any kind of doubts, you please let us know. Then we are going to have an awesome interaction between you and me and we'll give the best. Okay, now talking about what happened here, aluminum carbide on hydrolysis gives rise to methane and metal hydroxide, and here you have beryllium carbide on hydrolysis gives rise methane. So these are the two examples, it is only for methane preparation. Okay. So this is a direct question, direct equations from the NCERT, you can use it. Okay, once you are done, we can go ahead with isomerism and physical properties. Ready? Pratyush, Digvijay Singh, Anushka Rai. Perfect. So let's talk about Corey-House synthesis. It is a super important preparation for alkane. So you have various methods of preparation of alkanes. Decarboxylation, you have a reduction, you have Wurtz reaction, Franklin reaction, Kolbe electrolysis, and among all, everything has its own limitation. But you are from, so we are from, I just want to say Pratyush, we are from infinity land. Okay, we have infinite number of possibilities to crack NEET examination. Pratyush, all the best. Come on, let's focus here. Corey-House synthesis is the best method of preparation of alkanes. You can prepare even number, you can prepare odd, you can prepare branched carbons, you can prepare linear, everything. So Corey-House got, this couple got Nobel Prize for this Corey-House synthesis of organometal compounds. Okay, let's see the details about it. Alkyl halide react with three major steps will be there, Digvijay and Pratyush. Alkyl halide react with lithium in dry ether to form alkyl lithium. Rx plus Li gives rise RLi. So this is going to be a base rather a nucleophile. It is going to be a base rather nucleophile. Okay. Then it is reacted with cuprous iodide. This alkyl lithium reacts with the cuprous iodide to give rise dialkyl lithium cuprate. Dialkyl lithium cuprate. It is popularly known as Gilman's reagent. Very, very important. So commercially these Gilman's reagents are available. Okay. So this Gilman's reagents, this Gilman reagent is reacted with alkyl halide. This dialkyl lithium cuprate Gilman Gilman reagent is reacted with alkyl halide so that it is a good nucleophile. But here it is a rather a good base, and it is a good base. I just want to say strong base. So that you can't directly use it here. Rather, you can use it as a good nucleophile. Whenever it is a good nucleophile, you can see this is going to attack on this exclusively by using substitution nucleophilic bimolecular reaction. That's very important. So that you are going to see alkane. Okay, this is called as core house synthesis. The limitation, the key point in the NEET examination preparation. So this can be this first time you are using alkyl halide in this reaction, and second time also you are using alkyl halide in this reaction. Okay, so it could be primary alkyl halide, it could be secondary alkyl halide, it could be tertiary alkyl halide. Anything is okay. Anything is okay. But here second time you are using alkyl halide, na, it follows SN2, therefore it could be primary alkyl halide allowed, secondary alkyl halide allowed. If it is a tertiary alkyl halide, not allowed, because tertiary alkyl halide do not participate in alkyl substitution by molecular reactions. That's the reason why a product will be given. A product will be given what is alkyl halide, what is core house synthesis, which step, which alkyl halide should be used, that has to be given as a question. That's super important, very, very, very important. Okay, this is all about this core house synthesis. There you are going to expect a question from the NEET examination. Okay, Digvijay, any doubt? Keep asking. Any doubts you ask. Anushka Rai, Tribeni Rai, Pratyush, Chandan, Anurag Singh. Expecting doubts from you. Quick a doubt session beach mein. So take a snapshot, everybody. 3, 2, 1, click it. So this is the synopsis of core house synthesis. Yeah, Anushka Roy, doubts पूछना पहले. Yes. Now, in this reaction you can see Rx may be methyl halide, tertiary alkyl halide or secondary alkyl, primary alkyl halide or secondary alkyl halide. The alkyl group of the dialkyl lithium cuprate may be methyl, primary, secondary or tertiary. Okay, and this cannot be tertiary, that is a limitation. Next, physical properties of alkanes. So the physical properties of alkanes such as boiling point, density, solubility depend upon the intermolecular forces. What are the intermolecular forces that exist in hydrocarbons? Anushka, Digvijay, Pratyush, you tell me in the chat box. What are the type of intermolecular force that is there in the alkyl halides? Quickly. Quick. I am watching at this chart box. Watching at the chart box. So intermolecular forces that are present in this alkanes or alkenes or whatever hydrocarbons are going to be van der Waals forces. Van der Waals forces. Okay. So the magnitude of these forces of attraction depend upon the surface area of contact between the adjacent molecules. So I wanted to say greater the surface area, stronger are the forces. So I just want to say intermolecular forces is directly proportional to surface area. So the surface area is directly proportional to the molecular weight. So as the number of carbon atoms increases, its molecular weight increases, so size of the molecules increases. You know, the alkanes hydrocarbons always exist in zigzag structure. Zigzag structure means it goes like this, right? So let us talk about the details about this. So physical state, the normal alkanes C1, 2, C4 are gases like methane, ethane, propane, butane are the gases. When you talk about the C5 to C17 are colorless liquids, okay, and from C18 onwards they are going to be waxy solids. Okay, C5 to C17 which contain kerosene, petrol, gasoline like diesel and linen, all aeronautical fluids and loops and everything comes under this. Okay, और डार्क डेविल हाय एवरीवन बोले ना, पहले क्लास में सर को हाय बोलना है यार. दिग्विजय एनी डाउट? प्रत्युष, अनुराग सिंह, अनुष्का रॉय. ओके, अगर कुछ डाउट है ना तो आप पूछना. वंडरफुल. Next, now the boiling point of the unbranched chain. Alkanes show a regular increase in the molecular weight and increases by 20 to 30 degrees for each CH2 unit, mind it. And add at the chain, branching of the alkanes, however, lowers the boiling point. So very, very important, rule 1, boiling point is directly proportional to number of carbons. So I just want to say molecular weight. Now coming to rule 2. If molecular weight is the same, the boiling point inversely proportional to branching. There you are going to have a question in the NEET examination. Okay. So I just want to say here, which will have more boiling point here? Which will have more boiling point? A or B? Which will have more boiling point? Anushka, which will have more boiling point? Which will have more boiling point? Boiling point of A is greater than B. कैसे होगा? ए इज ग्रेटर देन बी, कैसे होगा मिस्टर यो? ओके, क्योंकि इसका रूल नंबर 1 के हिसाब से मॉलिक्यूलर वेट देखना। अरे मॉलिक्यूलर वेट कैलकुलेट करते जाते हैं क्या? देखो जितना नंबर कार्बन एटम, so as the number of carbons increases, molecular weight increases. Okay, anyways, when you talk about this is n-pentane, isopentane and neopentane, इसमें कुछ branches है नहीं, इसमें एक ही ब्रांच है। या इसमें एक ही ब्रांच है, इसमें 2 ब्रांचेस हैं। सो इसका ब्रांचिंग नंबर बढ़ते जाएगा तो बॉइलिंग पॉइंट कम होना चाहिए। नाउ यू कैन सी हियर माय डियर स्टूडेंट्स, इसका बॉइलिंग पॉइंट 309 एंड 1 ब्रांच के हिसाब से इसका बॉइलिंग पॉइंट 301। बॉइलिंग पॉइंट इज डिक्रीज्ड, यस और नो? इसका 2 ब्रांचेस का वजह से आपका मिलेगा 282। गॉट इट? Any doubt? So we have to check the rule number 1 and rule number 2. Clear? Fine. Talking about the melting point, it is a super important point. So alkanes do not follow very smooth gradation with the increase in the molecular size. The melting point order is completely different. So of course, as number of carbons increases, melting point also increases undoubtedly. But what happens, alkanes with even number of carbon atoms have the higher melting point than next to lower and next higher alkanes. I just want to say C1 and C2 and C3. So next odd number का melting point कम आता है, and C4 and it is going to be C5. Next odd number का कम होना चाहिए, C6 and C7. It goes like this. After some times now it is going to follow the regular trend. Understand? This is very, very important. This is very, very important. So even number has greater as compared to next odd number. Okay, so it is going to have a zigzag seesaw structure, so melting point and number of carbon atoms, right? Now let's talk about solubility. Like dissolves like, it is general rule of solubility, है क्या ना? So in light of this rule, alkanes which are predominantly non-polar, of course it's a pure non-polar, never and ever soluble in the water, and it is soluble in the organic solvents. And of course alkanes themselves are going to be a solvent in some occasions, like N-hexane is a solvent, cyclohexane is a solvent, okay, kerosene is a solvent. So N-hexane and cyclohexane are N-hexane is extensively used as a solvent, mind it, okay. And density. The density of alkanes increases with increase in the molecular mass till the limiting value of 0.8 gram per centimeter. This is the maximum density that can have because of the tight packing of the solid alkanes. That's the reason why this means that all alkanes are lighter than water. So alkanes float on the water. Alkanes float on the water. Assertion and reasoning type questions. Assertion. Alkanes float on water. The reason? density maximum of alkanes is 0.8 gram per milliliter. Therefore, no alkane can have the density heavier than water, so alkane always float on the water. Understand? Yes, moving ahead, reactions of alkanes. Before going for the reactions of alkanes, I just want to take you to somewhere conformations of alkanes. I want to take you to conformations of alkanes. Pretty important, alkanes show conformational isomerism due to free rotation of carbon to carbon sigma bond. So let's talk about ethane, example ethane. So the ethane contains carbon, carbon, a direct bond, hydrogen, hydrogen and hydrogen. Now this is the carbon. I want to show it like this, there is a bond. So in the Newman projections, everybody, Newman projections, this is the carbon, and I want to show you this Newman projection, this is the carbon and this is the carbon, there is a free rotation between these two carbons. Okay. Now I want to say the carbons are shown like this, so that it is going to be like this, only one carbon front you can see, rear carbon you cannot see. So there is a rear carbon present here. So that contain hydrogen, hydrogen, hydrogen. So I just want to show you front carbon का hydrogen आपको दिख रहा है इसे, and ये पीछे जो है ना rear carbon को hydrogen भी ऐसे दिख रहे हैं. You understand? Clear? Hydrogen, that is hydrogen. You understand? So this is one conformer. Whenever the carbon is having 3 bonds and 4 bonds like this, okay, so it can be rotated, so the relative position of the hydrogen of this and this is going to be changed. Let us make it 60 degrees rotation. So it is going to be 60 degrees rotation. It is going to be rotated. Keep the front carbon intact and make the rear carbon to rotate, so that you are going to get hydrogen, you are going to get hydrogen, you are going to get hydrogen. So what makes, these are the 2 conformers of ethane. Okay. So as this is dihedral hydrogens, carbon atom, hydrogen atoms of the adjacent carbon atoms are going to be very close because of the steric repulsions. It is going to be more energy and less stable. So this is called as eclipsed, and it is going to be staggered. So energy, daredevil, Anushka. So energy, staggered is greater than eclipsed. ठीक है, staggered is greater than eclipsed. And stability, energy का inversely related है. So that what happened, stability, it is going to be staggered कम है एंड एक के लिपसिड का ज़्यादा है, उल्टा लिखा में एनर्जी एक्लिप्सिड का ज़्यादा है, स्टेबिलिटी स्टैगर्ड का ज़्यादा है. आर यू गेटिंग और नॉट? क्लियर? Now let's see the conformation in the butane. Conformation in the butane. स्टेबिलिटी स्टैगर्ड का ज़्यादा होता है बेटा. या Now, let us focus on conformations of butane. Any doubt? Mr. Yo. Okay, conformations of butane. Conformations of butane. Yes, you can join in our Sri Chaitanya Educational Academies, okay, and you connect to the CS team, they are going to take you, okay. You completed your 10th examination, congratulations, and don't spam in the chat box, my dear children, and you can visit any Sri Chaitanya Academy across India, and you can have a inquiry about that, okay. Let us focus on conformation of butane. In this conformation of butane, you can see CH3, CH2 and CH2 and it is CH3. So, this is first carbon, second carbon, third carbon and fourth carbon. Among, thank you very much and God bless you for your journey. Okay. So, this is one carbon, second carbon, this is the third carbon. So, I want to take a conformation related to second and third carbon. Fine beta. So, let us see, this is your second carbon and behind that third carbon is there, right? And that third carbon is going to bear 2 hydrogens and 1 methyl group. है ना? So, that you can write CH3 and H and H, understand? And third carbon atom also going to have a methyl group and H and H. So, this is a Newman projection of this butane. Okay, you all understood now? So, let us write a 60 degrees rotation over here. So, when you rotate 60 degrees over here, so you are going to have a 60 degrees, okay. So, what will have? This is going to be moved up to here. So, I do not want to disturb the front carbon, I do not want to disturb the front carbon, it is going to be CH3 and H and H, and this is rotated from here to here like this, CH3, you understand? So, everybody do it, huh? Yes, like this, okay, got it, clear? Got it, clear? Okay. So, this is the second carbon, this is the third carbon, okay, this is the second carbon, this is the third carbon. Second carbon and for you, Mr. Yo, okay. So, second carbon and third carbon. Now, it is shown like this. What second carbon is having 2 hydrogens now? Second carbon is having 2 hydrogens and 1 methyl group. Even third carbon is having 2 hydrogens on 1 methyl group now. Now, fine, you understand, clear? Fine, you understand, clear? Yes, that is good. Okay, now if it is rotated 60 degrees, keeping the front carbon intact, rear carbon is rotated 60 degrees. Understand? So methyl group is coming in this way. That's good. और एक 60 रोटेट करना चाहता हूँ, और एक 60 रोटेट करना चाहता हूँ. So कर दो. You are going to see CH3, H and H. Okay. Now it is going to be CH3 and H and H. Okay. Now I just want to rotate 60 more degrees. Only 60 is permitted in the conformational analysis, my dear children. Now it is going to be, carefully see, so many conformers you are going to get it. In ethane you have only two conformers, one is staggered and eclipsed. Here you are going to get four conformers. So you are going to see CH3, H and H and CH3 and H and H. Now you got it? So this is what you can say. Totally it is eclipsed. It is called as a fully eclipsed form. Okay, it is looks like an eclipsed form, my dear students. It looks like an eclipsed form, but it is not eclipsed. So it is called as partially eclipsed. Okay, and it is like a staggered form. Okay, it is called gauche, and it is going to be fully staggered form is called as anti. It is going to be anti form. Now you tell me where the repulsions are maximum. Stability 4. Anushka Rai, now you are in the picture again. 4, again 2 is greater than 3 is greater than 1. Of course, I would give you the nomenclature. This is 1, 2, 3, 4. Energy, dear energy is going to be 1 is greater than 3 is greater than 2 is greater than 4. Stability, okay, 4 is greater than 2 is greater than 3 is greater than 1. So always gauche is more stable than anti. Got it? Everybody, if you have still any doubts, please let me know. Quick. So I want to change the examples now, expecting you to give the correct one. Yes, now I want to talk about CH2, CH2F, OH, 2 fluoro ethanol. For this two conformers, I just want to write OH, H, H, F, this is Cauchy, among these two, Cauchy and anti, which is more stable? Among these two, Cauchy and anti, which is more stable? Question is for you. Question is for you. One is more stable than two? Okay. Maybe Cauchy, okay, Mr. Yo, can you justify? Can you justify? When you take a Cauchy structure over here, fine? Yes, hydrogen bonding is there. Hydrogen bonding is there. Because of the hydrogen bonding, it is a super important hydrogen bond makes it is more stable. That's the reason why Cauchy is going to be more stable. Anti, exceptional case. Like that, so many things are there. Whenever hydrogen bond comes into the picture, no electronic effect, no other effects, it is going to take over. Anushka Rai, fine? Don't be maybe Cauchy. Cauchy is the correct answer here. Fine, my dear students, clear? Yeah. Now let us start with chemical reactions of alkanes. Yeah, chemical reactions of alkanes. It's a long session of 2 hours. Okay, stay with a lot of patience. Stay with a lot of patience. Okay, and we'll have very good reactions of alkanes. Are riding with me along? Okay. So, whenever you are preparing for some examination, it is required, you should have a lot of patience. So, that patience gives you a tranquil mindset. That tranquil mindset can make you to think. Otherwise, your thinking ability will come down. You will be turbulent. Okay? You will take a wrong decision. So that First you need to develop a lot of patience, that is utmost important. You understand? Clear? So, sit together and study and walk around for a minute and again study, never lose your focus. Now, let us talk about, so alkanes being highly saturated, completely saturated, okay. So, alkanes being completely saturated compounds undergo only substitution reactions. You can't add something because completely it is saturated. So, you have to remove one hydrogen and you have to replace with something. So, the carbon to hydrogen bond has to be broken. The hydrogen atom is replaced by other atoms like halogens, nitro and such groups, such are called substitution reactions. Such are called substitution reactions. Let us talk about halogenation, replacement of hydrogen by halogen atom. The halogen atom could be chlorine, bromine, iodine. Fluorine you can't directly add because it is super explosive. So, on safety grounds it is not allowed to do that in presence of UV light or the presence of heat. Okay. So, the substitution reaction follows the free radical mechanism. So, methane react with the chlorine to give rise to methyl chloride. The methyl chloride gives rise to dichloromethane. This dichloromethane react to give rise to chloroform trichloromethane, finally tetrachloromethane or carbon tetrachloride. Okay, it follows the bromination is same as a chlorination but is relatively slow and it require high temperature to make the reaction to get it forward. Okay, it follows free radical mechanism. The reactivity of these halogens, dear children, fluorine is greater than, chlorine is greater than, bromine is greater than iodine. My dear children, here when you see here the fluorination, it is an explosive reaction even in the dark. Okay. If you go with the chlorination, in the presence of light is going to be, it is explosive, and in the bromination require little heating, and iodination it is a reversible reaction. So, once you know these reactions, now you are going to see alkyl halides in the grade 12 also. Okay, get ready. Fine. Now, here the bromination is same as a chlorination but it is relatively slow and high temperature is favored. And one more important is of halogenation. I mean to say one hydrogen atom is replaced. So, ease of abstraction of the hydrogen, tertiary hydrogen is more reactive than secondary hydrogen is more reactive than primary hydrogen is more reactive than methane. And reactivity of halogens, as I mentioned, fluorine is more reactive than chlorine is more reactive than bromine, and it is, so bromination is same as of chlorination but is relatively slow and high temperature is favored, as I mentioned. Ayaz, yes. So, yesterday you were there in the class, Ayaz? Okay. The next is going to be the iodination is a reversible process. When methane is subjected for reacting with iodine, now it is going to get methyl iodide and HI. So, the reaction is going to be reversed. To make the reaction to be forward, HI has to be removed. So, we need an oxidizing agent. HI is a reducing agent, so oxidizing agents such as HiO3, you can use HiNO3, HGO or use it to oxidize HI. So, if I use Hi, it react with HiO3, gives rise H2O, and it gives rise I2. So that Hi being consumed, reaction आगे बढ़ता. Understand? Reaction आगे बढ़ता. And it follows the free radical reaction. So, reactivity and selectivity principle ये क्या होता है? Less is reactive and more is selective and vice versa. So, less is more reactive, least selective. More is the reactivity, least is the selectivity. You can see the reactivity, tertiary hydrogen is more reactive than secondary hydrogen is more reactive than primary hydrogen. Okay, chlorine is more reactive than bromine is more reactive than iodine. Now you see, chlorine is more reactive, so that whatever it is available, it is going to react. Whereas a bromine is less reactive, so it specifically want to take the tertiary hydrogen into the action. That's the reason why then isobutane is reacted with the chlorine at 25 degrees centigrade. So it can be chlorinated here or it can be chlorinated here. So this product can be and this product can be, you can see 63 and 37%. While you can see the bromination, bromine is more selective for tertiary because it is less reactive, it will wait and go for the selectivity, so that it is going to be brominated more prominently, 99% product milega. This is what is called as reactivity versus selectivity principle. समझ में आ रहा है क्या? This is very, very important. Surety करो. चिल्ले क्यों कर? ऐसे. Yeah. Let's talk about the free radical mechanism for this. Let's talk about the free radical mechanism for this. Yes. Banje. Okay. Free radical mechanism for the chlorination of methane. So mechanism for chlorination of methane. So it follows a free radical mechanism is very important. I want to take one important noteworthy point you never expect in any form of textbooks. You can see here. So it has three major steps: initiation and propagation and termination. Let's talk about initiation here. So initiation में क्या होता है आपका? So chlorine is going to be generating its a free radical, so that chlorine बीच में एक bond pair होगा ना. So ये जो bond pair है and it is going to be homolysis होने के बाद आपका मिलेगा 2Cl free radical. Okay, this is what is called as initiation. So this chlorine free radical is going to attack the carbon to hydrogen bond over here. So it is going to be attacked like this. So फिर भी homolysis होता है. So that HCl is formed and CH3 free radical is formed. Now it is initiated. Anushka Roy, now it is initiated. Okay. Now once it is initiated, it is going to be propagation. It is going to be propagation. In the propagation क्या होता है, जो CH3 dot, this is a free radical, is going to react with the chlorine. You see how confidently the mechanism is coming. फिर भी homolysis होना, so that it is going to be CH3Cl plus Cl. सो जब तक इसके पास हाइड्रोजन बचते रहते हैं, सो रिएक्शन आगे बढ़ते जाते हैं. आर यू गेटिंग और नॉट क्लियर? नाउ उसमें टर्मिनेशन में क्या होता है? सो इट इज गोइंग टू गिव यू CH2Cl2, it is going to give you CHCl3, gives rise CCl4. So it continuously forms this propagation step like this. Anushka, now let us see the suspense story over here. Termination. In the termination, the fundamental rule is whenever the A and B are reacting, one of the reactant is going to be limiting reagent, left of the things are going to be left. So remaining free radicals are going to join together to form the respective compounds. So what are the possible free radicals that are available in the reaction mixture? आपको पता करना है. So that is going to be here. Chlorine free radical चाहो, ये chlorine free radical है. Chlorine free radical है. It is going to get Cl2. Okay. And it is going to be CH3 free radical है. It is Cl dot free radical है. You are going to get a CH3Cl है. And also CH3 free radical है, CH3 free radical है, it is going to get ethane. It is going to get ethane. Little bit of ethane is also formed in the chlorination of methane. Can you believe it? Unbelievable, but it is. Because of the termination step, ethane is formed. In very, very important noteworthy point in chlorination, a small amount of ethane is formed. It is true. Statement 1, statement 2 types of questions. Can you believe it? Yes, of course, it is true. Got it, my dear children? Okay, next. Now we had a discussion up to here. Yes, you, Mr. Yo. So in this nitration, first we completed halogenation, and very important thing, nitration. Lower members mean to say methane, ethane, propane kind of things. So lower alkanes do not react with concentrated HNO3 at ordinary temperature. But long chain hydrocarbons, long chain alkanes on heating with HNO3 yields nitroalkane. So it is going to be hexane. So one of the hydrogen is substituted with nitro group. So nitrohexane is formed. So nitric acid is such a strong oxidizing agent, even that is vaporized. That is vaporized. Okay. So oxidation of carbon chain can happen, oxidation. And you can say, however, when a mixture of vapor of alkane and nitric acid is heated to 500, about 500 degrees centigrade, so nitroalkane is formed readily by this process. Lower as well as higher alkanes can be converted into nitroalkanes. Why? Because nitric acid at a high temperature, it is going to break the carbon to carbon bond and can give you the fragment of these alkanes. You can see methane, it is going to give nitromethane. Yes, it is possible even when you go with this 400 degrees centigrade and above. Okay, that's very, very important. This reaction is possible. Everybody please make a note of it. Okay, and in alkanes having 2 or more carbon atoms, there is always possibility of CC bond breaking. So at high temperature and a mixture of nitroalkanes is formed, like propane, you can break the bond. Nitration यहाँ पे कर सकते हैं, nitropropane मिले, ठीक है, but it can break it here ना. When it is break it here, you are going to get nitroethane and nitromethane, and you can go with the nitration at second position as well. So the possible products you need to know, when you write the nitration products. So no doubt which is major, which is minor is not the criteria, it is a random reaction. Okay, hey Suresh Kumar, कहाँ गए आप आया ना चार्ट बॉक्स लगते ओके हाँ, अब कैसे बेटा सुरेश, पढ़ाई कैसे चल रहे हैं? अनुष्का, okay, so let's talk about sulfonation. Sulfonation is done, yeah, lower alkanes, just like nitro, lower alkanes do not undergo sulfonation, but higher alkanes for the next hexane onwards, they are sulfonated slowly when treated with fuming sulfuric acid. Why I use the word slowly? Are alkanes are unreactive na, heat or kick, nothing, you can't make alkane to react. Okay, so they are also called as paraffins, mind it. So you can see hexane when it is treated with the H2SO4 in the presence of sulfur trioxide, so that's called as fuming sulfuric acid, hexane sulfonic acid is formed. Okay, hexane sulfonic acid is formed. Okay, that's very important. However, lower members such as propane, butane, pentane react with SO3 in vapor phase. Mind it, you have to evaporate it. Okay, and it forms its corresponding sulfonic acids. Okay, now let's talk about the cracking. It is also called as a pyrolysis. Pyro means heating, lysis means breaking. So alkanes, when it is heated to high temperature, it carbon to carbon bond is going to broken and it is going to form its fragments of lower alkanes. So this is the principal process that we follow in the petrochemical industry. So high long chain hydrocarbons are taken in the petroleum refinery companies. They are going to heat in at high pressure. So what happens? Carbon to carbon bond is broken. That is called cracking, and pyrolysis happens. So the fragment of the lower members of the hydrocarbons are subjected for distillation process, and petroleum and other kind of things are going to be separated. From petrochemical industries, more than 100 different types of sub-products can be isolated. Can you believe it? Yes, one of the emerging and most profitable companies, petrochemical industries. Mind it, here you can say here rupture of carbon to hydrogen takes place and rupture of carbon to carbon takes place by using, you see carefully, the rupture of carbon to hydrogen bond takes place when you use chromium oxide, vanadium oxide, molybdenum oxide. carbon to carbon bond can be ruptured when you use silicon dioxide, aluminum dioxide, aluminum trioxide or zinc oxide, mind it. Okay, Suresh, Mr. Yo, Anushka. So in the YouTube platform, students are getting a super benefit of this total content. We are not compromising. Since 2 hours I am talking about alkanes, we are not compromised with the content. Okay, and we are giving valuable information for those preparing for NEET examination, and हम लोग बच्चा के लिए कुछ भला करने का कोशिश कर रहा हूँ. So you take it and just use it, and please like our session, share with your friends, subscribe to Infinity Land YouTube channel, and do attend our classes on a regular basis so that you will understand. Okay, so you can see C2H6 ethane on cracking gives rise ethene and hydrogen. Okay, propane, you are going to get propane and hydrogen. Okay, like that you are going to have whenever your seen CR, here is CR. Okay, based on these conditions the products are going to be relatively changed. Okay, reaction with steam reformation, you can say methane is mixed with steam. This is the steam. You know, under this temperature 1273 in the presence of nickel, you are going to get CO and H2. It is called as water gas. Okay, so mixture of CO and H2 at any proportion, you can say as a water gas, whatsoever the source may be. And this is a super important gas it is very, very important industrial fuel. Okay, combustion. So complete combustion and incomplete combustion, two things are there. Okay, dear children, we are at the end of the session. Please be alert. So that is, you have to make me to give more energy in the class. Hey na, Anushka Roy, Ayash and Mr. Yo, Suresh Kumar, chat box में थोड़ा सा आपका discussion पता करने तो हमको भी भला होगा ना. Okay, methane, when it is completely subjected, any hydrocarbon is subjected for oxidation and burning, combustion, it is going to give us carbon dioxide and water, and huge amount of heat is liberated. So that these reactions undoubtedly exothermic reactions, and of course these are used as a fuel. And in the generous reaction, CnH2n plus 2 can give us 3n plus 1 by 2 number of moles of oxygen is reacted in the combustion process to give rise NCO2 and n plus 1 number of water molecules, and the heat is released. And this reaction can be used for eudiometric calculations, thermodynamic calculations and various things. Okay, and incomplete combustion में क्या होगा? You are going to get carbon black or carbon monoxide. Carbon black or carbon monoxide when you subject it for limited supply of oxygen. है ना? So we are done with, this is the carbon. Methane is reacted with incomplete supply of oxygen, is going to get a carbon black. This carbon black is used in the preparation of black ink, paint and polishes. Okay, so we are done with isomerization, and one more reaction, aromatization. So when alkanes are heated with anhydrous aluminum chloride, you are going to get isomeric products. So long chain isomers are going to get a branched chain. So this is called as isomerization reaction. Butane, N-butane is converted into isobutane. Okay, and N-hexane is converted into mixture of 2-methylpentane, 3-methylpentane. Are you getting or not? ठीक है? Okay, fine. Mr. Yo, are you there in the class? Suresh Kumar, Anushka Roy, Tribeni Roy, okay, all are waiting here. Okay, so the last equation of the question, okay, and aromatization is also there. And so this is a synopsis that can give you what are A, B, C, D in this reaction. Quickly tell me, what are A, B, C, D in this reaction? So it is going to be 1-bromo-3-methyl butane when it is reacted with sodium in ether, and various reactions are there. And so if this is the product, you can say what could be A here, it is an Grignard reaction. What could be the B here, it is of course a reduction. What could be the C, it is going to be Wurtz reaction. And what could be the D, it is a Korehouse synthesis. So this kind of things can give you a super important insight and overall picture about the alkane. Today we had a discussion completely about alkanes, and day after tomorrow again we'll meet with an alkene and alkyne. Are you getting or not? So that is a part 2, hydrocarbons. So let us join in our awesome journey with organic chemistry and physical chemistry and organic chemistry. One such sessions, get ready. So we are done from today. So we are signing off. Suresh, Faculty of Chemistry, and please like the session, share with your friends, and subscribe to Infinity Learn YouTube channel. Thank you. Stay with us, and if you find any doubts, you just put in the chat box or in the comment box. Thank you very much. Bye bye. God bless you.